Good afternoon, everyone. Thank you for joining us for the IAEOZ Summit. My name is Melvin Anderson, and we have a great panel for this afternoon. Precision farming, innovative technologies, digital tech, drones, energy, transition fuels. Today we have Cam Saidi. He is with us from U.S. Department of Commerce. Sensing and Perception System Group, National Institute of Standards and Technology, U.S. Department of Commerce. We're going to have a great show, great presentation today, and everyone just sit back and relax. And if you have any questions, please hit the Q&A section of the site, and we will get those answered for you immediately. So, Cam, have at it.
All right. Thanks, Melvin, and thanks the IAEOZ Summit team for inviting me to speak. Let me queue up my presentation and see if we can get that going. All right, so I wish this was the title of my presentation, but it's not. Obviously this summit is about agriculture. My work is not necessarily in agriculture. So I'm not going to be talking necessarily about drones in agriculture, but what I'm going to be talking about is what NIST has been doing in SUAS performance and pilot proficiency. SUAS, small unmanned aircraft systems, or more commonly known as drones. Of course, drones can be pretty big. So when we say small, we're talking about generally under 100 pounds, preferably under 55 pounds, because there are special FAA rules that apply to under 55 pounds. Now, for agriculture, that 55 pounds may not apply, and it may need to be heavier for certain applications. I want to talk a little bit about the background of what we're doing, talk about some of the basic skills tests that we have, and then talk about some other tests that we also have. There's going to be a lot of information in here. I'm going to try and go through it quickly because of the time limit. And hopefully some of it will stick. Please ask questions. I think that's the best way to really understand something. Like I said, there's a lot of information, and if there's something not clear, please feel free to ask questions. So let's get into a little bit of the background. The project that this falls under is called the Emergency Response Robots Project. It's led by Adam Jacob, and I am one of the team members on this project, among others. So we are part of the Intelligence Systems Division at NIST. We're in the engineering laboratory. So if you're not familiar with NIST, NIST is an agency that's part of the Department of Commerce, just like NOAA, the National Oceanic and Atmospheric Agency. NIST's mission, as mandated by Congress, is to help U.S. industry be more productive, more efficient, and more competitive globally. And we do this by developing science, measurement science, and developing technologies that can help U.S. industry. And we like to really help industry develop standards. And when most people think about standards and NIST and Department of Commerce, they think that it's the government imposing standards. It's not. We like to work with industry to develop voluntary standards, industry standards, not government standards. There are a few standards, yes, of course, that we develop for government use and that are then used by industry, and you may be familiar with some of those, such as encryption standards, data encryption standards, communication standards, and so on. But for the most part, it's voluntary standards. Now, this work is largely sponsored by the U.S. Department of Homeland Security, and it's being developed in collaboration with ASTM International. ASTM International is a standards development organization, and we basically have a subcommittee on response robots for Homeland Security applications. It's E54.09. At the bottom, you'll see the website for our project, robottestmethods.nist.gov, as well as the email, robottestmethods@nist.gov. I'll have those at the end as well. It's a very good way to find out more information and to ask questions. All right, so let's get into it. So what we have developed is over 50 test methods for evaluating the performance of various types of robots. The robots that we are interested in are robots, whether they roll on the ground, they fly in the air, or they swim on or under the water. And their main use, emergency response, means it's in situations where it's dangerous for people to go into, and such as nuclear accidents, structures after earthquakes, fires, anything where it's dangerous for people to go into. First responders would like to be able to send robots. Now, a lot of times, companies that are developing these types of robots will have very nice marketing material about what the robot can and can't do. Mostly it's what it can do. But not all the time those claims end up being valid. And so early on, back into the early 2000s, some first responders started talking to us to figure out, well, how do we know which robots can actually do what they say they can do, so that we know which ones to buy and so that we know which ones to deploy. And so we started working with them, and we eventually broke down the capabilities of the different robots into different categories, such as mobility. So what you're seeing in the video, small video here, is a robot going over different terrains, how mobile it is over different terrains. It's categories such as dexterity, endurance, how good are the sensors, how good is the radio communications, durability, and so on and so forth. So we look at all of these different types of capabilities, and we look at many different types of robots, as I said. So robots can even be humanoid robots, and we've run competitions based on that as well. So what we're doing, so for example, let's say a first responder organization has a need for a robot, and they are presented with 6 or 7 robots that need to go over certain types of terrain. And this is just an example of sand, gravel, flat terrain, and then different types of terrains that are more difficult, ramps, continuous ramps, step fields. So what these test methods allow them to do is to run each robot through each of these tests and get a score for how good that robot did. In this case, the metric that's being used in the chart at the bottom is meters per minute. So how fast was the robot able to go over these different types of terrains? And so then they can look at each robot, so there's robot A, B, C, and so on, and look at the scores in each of the tests. And if they needed a robot that could do really well in all of these terrains, they would pick robot H at the very last right side, because it did well in most of them. But maybe robot H is too expensive for them, so they may say, okay, well, we're willing to settle for robot G. But essentially what it allows them to do is to quantitatively figure out how good the robots are at doing the tasks that they need them to do. Now, we have, like I said, more than 50 tests that we are able to run, so not all robots will be able to do all 50 tests, and not all first responders will need a robot that can do well in all 50 tests. So typically what they do is they select a subset of tests that defines their mission, and then they run the robots through those tests to figure out which robot best meets their mission. And again, when I say robot, I'm talking about, it could be a rolling robot, it could be a drone, it could be submersible, it could be many, many different things. The other thing that we are able to do with these tests is to evaluate not just the robots, but the operators of the robots. A lot of these robots are teleoperated, and so there's a human in the loop somewhere, and some robots have more autonomy than others. We like to encourage as much autonomy as possible, and a lot of the drones have a significant amount of autonomy relative to the ground and underwater robots. So it allows us to evaluate how good the operators are. What you're seeing here is a chart of different operators running not all the same robot necessarily in this case, but running different robots through the same set of tasks. And it was a series of 10 tasks or so in a 30-minute time, and they then they did as much as they could, and they got a score. And so here you can look and see how the different operators score relative to each other. The orange bars that are really high up at the very far left, those represent the expert operators. So the people that are best at driving whatever type of robot they were driving, then typically they come from the makers of those robots, the manufacturers. And then you can look and start looking at averages. So for example, in this data set, there were civilian operators and military operators of robots. You've got the civilian average and you've got the military average, and you can see the military average is slightly higher than the civilian average. And then you can, break it down into however you want based on your own organization, what's the average in there or in your region, and then you can start comparing yourself to others. But usually the gold standard, or the best that the robot can do, is defined by the expert operator. And then you can strive to get as close as possible to that expert operator. So let me talk a little bit now about the SUAS, or drone tests, that we are talking about here. These are just examples of some of the drones that would fit in the SUAS classification. And our initial focus is on rotary wing, which means these types of drones that can hover in place in the air, as opposed to the fixed wing drones, which have to fly forward in order to maintain lift. Some of the tests apply to fixed wing drones if you scale them up enough, but for the most part, we're still focused on the rotary wing aircraft at the moment. So the types of tests that we are developing, and again, as I mentioned earlier, we break them down into different categories: sensing, maneuvering, energy, and so on. So this is just an example of some of the tests that we are working on. The main ones that we're going to be talking about here and that we've been focused on very heavily are these what we call basic maneuvering and payload functionality, and they're comprised of 5 different tests, and I'll talk about them in more detail. The main theory behind all the tests that you will see in this presentation, and if you've ever seen these tests in person or in video, you'll see a lot of buckets that look like this. Inside of the buckets, usually we've got rings of different colors and different sizes, and we've got usually a number with a letter just to identify which bucket you're looking into. When you're flying in the air, and most of these drones have cameras, you can aim the camera into the buckets, and as long as you see most of the some of the green ring and the black ring that goes inside it, you're aligned with that bucket, and that means you're in a certain position in the air, and then we can judge at how well you maintained or you got to that position just using the camera on the drone and the buckets that are typically on the ground. And this gives us an easy, cheap, repeatable way of figuring out where you are in the air, instead of having to use very fancy equipment to do that. In addition to the rings, so some of the rings I mentioned are colored and some of them are black. The black rings can also have a break in them, and we call these concentric Cs because they look like a C. And so we have 5 different sizes of these Cs inside of the buckets. So when you're doing a payload functionality test as opposed to maneuvering test, and I'll explain a little bit more in a second what that means, you would be looking at first aligning yourself with the bucket and then reading which orientation the openings in the Cs are, and seeing what's the smallest C that you can see the opening in, and that defines basically also your score. So these 5 tests that I mentioned, they're position, traverse, orbit, spiral, and reconnaissance. Each test can be run either as a maneuvering test or as a payload functionality test. Maneuvering test means that you're just evaluating how well you can get the drone in certain positions in the air and perform certain maneuvers. Payload functionality test means that you're still doing the same things as the maneuvering tests, but at the same time, you're using your payload, which could be a camera. In this case, it is a camera. It could be a thermal imager. It could be a radar. It could be a LiDAR, many different things. In this case, we're talking about the cameras. So you would run the same test that you would in maneuvering, but you would use the camera to evaluate how good you are at using the payload, or the camera in this case. All of the tests use this setup, this apparatus that you see in this picture, and the buckets. You see the buckets are on the ground, so you're flying from one bucket to another and looking in different buckets to get your position in the air, and you're doing all of these different maneuvers. The altitude of the drone in these tests is defined by the spacing between the stands, so stands 1, 2, 3, and 4. If the spacing is S, then your altitude could be S or 2S in these tests. So it's up to you to figure out how high you'd like to fly, and then you set the stands at that distance apart. So the position test looks at how well you can hover in place and how well you can do some very basic maneuvers. So think of these as kind of the basic driving test for you to get a driver's license. That's how we imagine these. And it looks at how accurately you can land as well. And if you're doing, of course, the payload functionality, you would be looking at the C's inside the buckets, not just aligning yourself. This is kind of what it looks like. Hopefully the video is coming across. This is what it looks like from the drone on the right and from a simulated drone that's being actually flown by a person using the same remote control that they would use to fly the real drone. Just to give you an idea of what it looks like when you align with a bucket, when you look in, when you're trying to read the C's, and then what are the different maneuvers that you would be doing. I'm not going to go through exactly what the maneuvers are. All of that information is on the website. I'd be happy to take questions about that as well if you want. Traverse is the second test in this basic skill set of tests, and it looks at how good you are at flying sideways, both in left and right directions, and again at how well you're able to land, how accurately you can land. Orbit is looking at how well you can, as the name suggests, orbit an object, and we do it at 2 different altitudes. And again, you go once in one point left orbits, and in the second point right orbits. Spirals, this is more of a free flight maneuvering or payload functionality where you're free to fly at any altitude or as close to the buckets as you want, but we do define which direction you inspect the first stand, the second stand, and so on. And then speed or reconnaissance is looking at your ability to go in a straight line and how fast you can do that. And of course, all of these tests, we run them not just once. You have to run a predetermined number of repetitions without any failures in order for you to score on the test. So what we're looking for really in these tests, the primary measure is completeness. Did you finish the trial without any failures or faults? And if not, well, how far did you get? The secondary measure is your score. What was your score? And so, did you get 20 points? Did you get 10 points? And the last optional measure, which a lot of people do like, is how many tasks or points per minute did you do? And so then you can start comparing yourself. If you scored the same as your colleague in your organization, well, then now you can differentiate yourself. Well, yeah, but I did it much faster than you because I was able to do 20 tasks, or 5 tasks per minute, or whatever it is. This is kind of what it looks like for a payload functionality test. You can see here, usually we like to get videos from what the drone is seeing, which is on the top left, what the operator is doing with the controls, what the drone looks like from an overview picture over the test, and then detailed shots or close-ups of the drone while it's flying in the air. And so you can see here the operator is zooming in. They're doing a payload functionality test, so they're trying to zoom into the buckets to read the C's, and then they're searching for the other bucket to do the same thing. Okay. If you go to our website, there's detailed instructions on how to fabricate these things, these tests, how to run them, what materials you will need, posters that you can download and print. It's all available on our website.
Okay, thank you very much, young man. Excellent presentation.
Sure.
Thank you for your time. Let me see if you have any questions. None at this time. Is there anyone out has any questions? You can always type it in at the Q of A. Thank you very much. Jose, I'm going to bring you up. So tell everyone about yourself, young man.
Jose Nino. I'm here at the Nino Group. And I live in the Washington, D.C. area. I'm the former president of the United States Hispanic Chamber of Commerce. We are working in various areas to help companies do business with the federal government. At this point, on this particular panel here that I was invited to help moderate, it's to bring together some folks that can talk a little bit about the different areas of interest as you have seen it today on precision farming, innovative technologies. You just heard about drones and robots. And as we were looking at it, I'll save some questions for after the other panelists also speak. So if it's okay, at this point, let us bring in No Carroll of BioFriendly. And No, you're on.
Hi, thanks for having me. Can everybody hear me okay? I want to make sure I'm here on there. Yeah, good. All right. So yeah, thank you for having me very much. I'm excited to be here for the summit, for the first one, and hopefully for many more to come. What I like to talk about today is agriculture in the age of energy transition. Again, my name is Noel Carroll. I'm the CEO of BioFriendly. BioFriendly is it's basically a green technology and education company. We started off, the company was founded to reduce fossil fuel air pollution. I came aboard in 2018. I was jumping into a business in transition. I think that's what's interesting about our company is we're a green company. We're a company about the environment, but we're also a company that was working with fossil fuels. So there was sort of a realization within the company that this is they don't always work well with each other, the two concepts, and also with the age of electric vehicles and sustainability and new sustainable energy options and things like that we had to start looking at what was this company going to be in the future. So I came into a business in transition and expanded it basically. So our company now has really gone into education through media and entertainment through media, as well as finding new technologies and investing in new technologies that have to do with the environment. I also came from the entertainment industry. I worked with Warner as a producer, as well as Shoreline Entertainment and Samuel Goldwyn making films and series and commercials and things like that. The first thing I did when I came on was I created BioFriendly Planet e-magazine, which is one of the fastest growing environmental websites on the net. And we created the BioFriendly podcast. So that ridiculous picture is me and my co-host, Jacob Gibbons. And that's, this is all going very well and growing very, very fast. But through doing all this, I found myself as an educator and activist in green innovation and sustainability, where I get to speak at events like this and talk about these kinds of things. So to talk about environmentalism, in U.S. agriculture, the first thing I want to point out is just an interesting starting point where you look at kind of the major industries, and all of them are much bigger polluters than we are in agriculture. Transportation is 28% of the greenhouse gas emissions. Electric industry is 27%. Industrial is 22%. Even commercial and residential is more. And I think that's an important point. The moderator here, Jose, and I have a joke that we say to one another. It's that we were green before it was cool because we both came from farming families. My family's Australian. I don't sound like it, but I am. I was born and grew up here, but my parents and everyone else they're Aussies, and we came from farming. And it's a green industry by default, right? I mean, it's an industry where you preserve biodiversity, you're growing crops, you're raising animals and protecting soil, literally by doing the job that's being done. Another thing that's interesting about the agriculture industry is that before you start, there's already a carbon offset. You're already reducing your emissions just by doing the business you do, right? The EPA estimates that 11.6% of the carbon emissions that come from the agricultural industry are offset just by growing crops. And those crops absorb CO2 as they grow. It's also an industry that doesn't get forced to go greener or forced to get more efficient, or it just does it. It does it because it's an industry that's necessary for survival, right? So in order to successfully grow food at the rate that we need to grow food and keep people fed, it has to stay at the front of technology. So there has been a ton of advancements that are by default green, just because they're making everything more efficient. So it's an important point to note, because it's already a green industry before we start. In other industries, energy transition is easier, right? There's a global push for renewables and for incorporating sustainability in these other industries: transportation, construction, power generation, all the rest of it. You have other companies supporting. A great example is Tesla, right? So when you talk about the car industry, the transportation industry, you've got this disruptor that came in, made a very cool car. Some people find it cooler, others don't, sure, but it's definitely one of the best you can get. And they did such a good job of marketing it and getting it out there that now basically every auto manufacturer in the world is hustling or has already made a electric vehicle. So that's kind of an example of what's happening in other industries. In construction and in industrial applications, I mean, you're finding tons of options for conserving water, for improving waste, and for reducing waste. Solar panel options, and those are in agriculture as well. But there's tons of ways to get solar panels. In fact, I even read recently an article about how they're wrapping the Luxor in this like film that is entirely solar, to make the whole Luxor pyramid in Las Vegas into a solar energy, a generation machine. So there's support in those industries. I mean, and then of course in electricity, power generation, you hear about all the time. You've got wind options, solar options, hydro options. These simple, cheap solutions and supporting solutions aren't really offered for agriculture. It's you're kind of left on our own. Excuse me. So there'll be some challenges for energy transition in agriculture. According to the Food and Agricultural Organization of the United Nations, we're looking at a potential 9 billion population by 2050, which means that we're going to have to increase the amount of food that's being produced by 60% in order to meet that need. So you're being asked for more, but not getting cost-effective electric substitutes for diesel engines. I mean, there's some stuff out there. There's some cool stuff that's being made. I just saw a video with I think a John Deere, a little tractor on a, it was on a cord, but it was still pretty neat, and was automatically running around doing the job, but it was small. And while the work is being done, more needs to be done. We're not quite there yet, so we're still reliant upon diesel in this industry. There are solar grants that help a lot, and a lot of farms are using solar options to improve their sustainability, but charging equipment overnight isn't necessarily a sustainable option for this industry. It's much easier to fill up a vehicle with diesel. So it's an interesting problem, because you're being asked to do more, but not given the same kind of background support as other industries are. So what do we do? This is where I become the salesman for a minute and then talk about the product I mentioned at the beginning, which is Green Plus Energy Transition Fuel. Green Plus, which is this company's flagship product, it's an additive that turns diesel fuel into green fuel. It was the first additive to be designated as an energy transition fuel solution by UNITAR and the CIFAL branches of the United Nations. It's verified as an emissions reducer in the state of Texas, and we're in about 60% of the diesel fuel in Texas with that verification. We have over 11 billion gallons of fuel have been treated without any negative effect or harm to the vehicles. Over 8 million tons of CO2 have already been prevented from entering the atmosphere because of Green Plus. And to make a kind of a way to show that more easily for you to imagine, it removes the emissions equivalent of a 200-mile lineup of cars every year from the road. So it's a pretty cool product, and we're happy about it. We think that farm tractors, combines, irrigation pumps, and other equipment like that, these are the workhorses in an industry that literally keeps us alive. So with an increasing demand for food, but without the support of renewable technologies here yet, and again, I do think they're coming, you can see they're on the way, we think that Green Plus is a nice, sustainable bridge for that gap to get us from where we are today to where we need to be as a sustainable planet without harming the industry and without getting in the way of the increased demand for production. Our eco label with the United Nations, it certifies a reduction of greenhouse gas emissions by 7%. So we think that treating, just an additional 7% with agriculture can be very helpful. and it's a renewable option to bring to the industry that I think hasn't been given enough attention for it. That's all I've got. Thank you so much for your time, and I'll pass it on back to you, Jose.
Thank you very much. Thank you very much there. Let me ask you guys a couple of questions.
Sure.
Beginning here with BioFriendly. Are you currently supplying the farming industry with your product, or how's it being used?
Yeah, so in Latin America, there is some. In Mexico, we're seeing some use of the product for that purpose, and they're very happy. They're actually finding better emissions improvement than even we find in the United States.
Right.
The fuel's a little bit. It doesn't have all of the advancements we have to our fuel here. We actually have a pretty good standard of fuel in the United States. But in Latin America, they're using it and getting 15% reduction in their greenhouse gas emissions. So we're seeing it there, and a little bit also in Brazil, and we'll keep working on expanding that and doing that elsewhere as well.
Good, thank you. Kamal, question for you. You talked about robots, and they're being used for many different aspects. Can you expand a little bit? For example, the drones that were used 2 years ago, after maybe 3 years, when Houston was flooded, they were used to go in there, and it was a search and rescue.
Yeah.
Block by block, house by house. Can you talk about that a little bit, please?
Yeah, so drones, as you mentioned, are used in many, many different applications. In terms of search and rescue, a lot of times they're used with thermal cameras to locate people when they're doing search and rescue, to find heat signatures, essentially. But a lot of times it's also just to guide the first responders who may be on the ground or on the water, in this case, looking for victims. Sometimes it's much easier to see what's going on from the air, give a bird's eye view, essentially, and then guide the responders who are actually on the ground to different locations to search and so on. But what I also wanted to mention was that in terms of agriculture, so the reason why I was presenting what I was presenting is because a lot of these drones they still have a human in the loop. And so piloting these drones, even if it's got a lot of autonomy, takes some skill. And you need to know how skilled the pilot of your drone is before letting them do your missions, whether it's agriculture or search and rescue or whatever it is. And that's why I was talking about the tests that we have been developing.
And as you develop your tests, and you're moving forward on the farming side, there's all kinds of ways for the drone to pick up all kinds of analytics that can be used down the road. Can you explain how that's being done?
Yes, there's all sorts of ways that's being done. A lot of times, especially in search and rescue or fire or things like that, first emergency response applications, there's a live stream that's going from the drone to the incident commanders, who then direct where the drone should go next and what the responders on the ground should do. There's a lot of research going on, and because you've got multiple assets feeding information from the air, from the ground, whatever. How do you process all of that information quickly without having 20 people looking at different data streams? And so there's a lot of research on AI for analyzing that kind of information and getting the relevant decisions made really quickly.
Thank you. Looks like we were joined by Robin now. You're on now. Please introduce yourself and welcome.
Okay, thank you so much. Thanks for having me. Just want to say good morning. My name is Robin Parton-Pate, and happy to be here today with all of you guys. I'm excited about the Innovation in Agriculture Conference. There's a lot here. We have a lot to talk about with regards to innovation in agriculture, energy opportunity zones, and so much more. I think really just ecosystem collaboration is always really positive because we can learn from one another and talk about some of the impacts that can happen. Just want to begin with a thank you to our conference organizers who invited me to speak in this conference. Keith Moore, thank you so much. And then also panel moderator, Jose Dino, thank you so much. You guys have been gracious hosts, and also Melvin, thank you to you for helping troubleshoot with the Teams this morning. So for those of you guys that use Teams a lot in your regular roles, it's easy to stay logged in and you have to tell your computer a few times that no, you do in fact want to do something different. So just a heads up for those other presenters that may be having challenges.
And I'll have you teed up. Give me 30 seconds and I'll have you teed up.
Okay, all good. Also want to thank my fellow panelists. I think we can all learn from one another, and I'm really excited about what I just saw. Some of it definitely aligns with what I'm about to talk about in terms of use cases for some of the technologies, because technology and commercialization doesn't mean anything unless it can be brought to market and unless we have the people to help manage this. So definitely awesome panel in terms of what we're talking about technology wise. I was recommended for this panel by former colleagues and friends from the Manufacturing USA Network, Lisa Franchtuck and General Nick Justice from NC State. So thank you to both of you guys as well. I can't see your faces on here, but I'm sure you're here and just want to say thank you. So again, my current role is Chief Marketing Officer for Greenpoint Research. And my previous role prior to this was Chief Operating Officer at IAEOZ, the Composites Institute, which is the Institute for Advanced Composite Manufacturing and Innovation. So I think it's not a good government-funded organization unless there's a really long acronym. So just like this conference has an acronym, and my previous company did as well. So that's kind of part of the charm. And in my previous role, I had the opportunity to work with one of the Manufacturing USA Institutes. Right now, there are over 14 of them, and we'll see that on a future slide, some of the impact that's happening there in terms of ecosystem collaboration and overall opportunities for engagement. So do I go to the next slide? Okay, fantastic. And again, I talked about research to commercialization and really technology innovation. So again, it doesn't matter if you have the most awesome technology in the world. If it can't get to market and it's not solving a business problem, then it doesn't matter. So we'll talk about the power of partnerships, we'll talk about impact, and we'll talk about some best practices. And I told you guys a little bit about Greenpoint Research. We are headquartered in Florida. We represent the combination of agricultural, business, and political acumen, and we're a leading hemp company with one goal in mind. That's to become the largest low-cost cultivator and process of hemp biomass in the U.S. to provide a consistent supply of CBD to customers and manufacturers worldwide. Three of the key challenges we are trying to solve for the U.S. include affordable medicine, renewable energy, and sustainable agriculture. And here's a little preview of some of the things we do. We work on a large scale in terms of hemp farming and processing. We don't just want to sell farmer seeds. We want to be part of the overall solution in terms of helping hemp grow in the U.S. and help farmers be successful. So we want lower prices on sustainable products. We know that that matters. We want to attract institutional purchasers and social influencers because we know this is really important. And we want to attract mainstream purchasers, people who are not just experimenting with R&D, but who are actually large corporate customers. So some of the large chemistry companies are examples. So I can't talk about some of the information that might be proprietary, but there are a lot of companies right now that are looking at hemp. There are over 25,000 uses for hemp. So there's a lot that's happening in terms of R&D and how we can work together. It's really part of this conference is to talk about the power of the supply chain. And so that's one of the big things that my current company does. Okay. So one interesting presentation that I was a part of several months ago when I was part of my last role was a presentation from Bloomberg. And I thought this slide really summed up a lot of what we wanted to talk about at many conferences, but really big picture in terms of innovation. And that's the future of industry. And there are a couple of different circles highlighted there where I think we all have an opportunity to work together. So one of which is advanced materials. Obviously, because I'm in the hemp industry, I think hemp is an important material. In my previous company, we worked with mostly composites, so carbon fiber, polymer composites, things like that in the auto industry and then other industries. But one of the interconnected themes there is that sustainable materials and a circular economy go hand in hand. And they're not just important to these respective areas, they're important to America in general. And so one of the ways we can do that is by working together throughout the supply chain. And that kind of gets up to the digital industry circle above there. So how do we do that? So it's people, it's process, and it's prototyping, and it's a lot of different things. But There are a lot of different ways we can work together. We just have to be mindful of how we do that. So from a digital industry perspective, we're thinking of the Internet of Things, technologies, platforms. I was really excited to see all the work happening at NIST with regards to drones. And there's so much more that can be done. I mean, this is really the tip of the iceberg in terms of having the unmanned aircraft as a solution for a lot of our operational challenges to help us be more efficient so that we can spend our time on other things. There's also advanced analytics and automation. There's a lot there in terms of interconnectivity of themes and machinery talking, and also digital model reevaluation. There's a lot that can be done when data are talking, not just the data talking, but again, efficiencies at scale. And we'll talk a little bit more about that in some of the next slides. And so I mentioned a little bit about what I did there, again, in the materials space, but there are a lot of different institutes there. And ultimately, those institutes, you guys have probably seen this if you've been to any type of presentation with the institutes, but it is a good one because you guys have referred to it, I think, twice already in this conference, which is how do we bridge the gap? How do we make sure we don't have market failures, especially in terms of pre-competitive applied manufacturing research and development. And agriculture, even though it's in the agriculture space, I think the MOU signed with Department of Energy is really important and work that should continue just because it is important for everyone to work together and to look at that manufacturing readiness level and where we can have the most impact. So these institutes are put together to collaborate and catalyze impact within the ecosystem, especially with regards to that gap area, the valley of death you guys hear about. And that's very true. And so I do have some examples where we work together in that role, but then also some things we're doing at Greenpoint that are innovative and could lend very well in the agriculture space. Okay, so at a high level, we had about 65% of our members were from industry. We did a lot in terms of training. Again, it's not just the technology, it's the training and the ready and available workforce, which is excellent because that ties to the next slide. Ready and available workforce is one of the key challenges. We can talk about technology all day, but any meeting that I ever went to with funders, whether it was state partners, whether it was from industry, or whether it was meeting with folks on Capitol Hill, this was the #1 challenge that people were having in various different industries. So one of the things we looked at IAEOZ, and one of the things we're also looking at Greenpoint is how can we make sure we are able to scale our technology and get it in the hands of those who need it. So we need a willing and able workforce. We need them to be trained, and we need to meet people where they are. We've talked a lot about diversity in this conference, but there's a lot more that should be said. So for example, we need people with diverse backgrounds. That also includes diversity in thought, diversity in experiences, diversity in so many different areas, whether it is educational background diversity, whether it is where someone grew up, whether it is what market they're in. So for example, there are a lot of synergies in energy and agriculture and manufacturing, and a lot we can learn from each other. So again, looking at this graph, this is one of my favorites just because you can really see we're trying to meet people where they are, workforce development and education wise, and we can't assume that a one-size-fits-all approach will work for everyone. Keith talked a lot about the future generation and how are we going to get them engaged. We need to think about this K to gray. It's not kindergartners, it's not just STEM projects, it's kindergarten. How are we engaging them? How are we bringing about that awareness to gray? When we look at the incumbent workers, when we look at future retirees, how are we making sure that we are keeping them engaged, helping them learn about the new things? So who is the farmer of the future? Well, it might be someone who can run a drone. It may not be someone who can run a tractor. Maybe someone who runs a self-driving tractor. It may just look a little bit different. I know a lot of people are afraid of robots, but robots can actually be incredibly helpful in this process. So again, just thinking about this from K to gray, how do we meet people where they are and how do we include diversity in thoughts and experiences? Because there is something for everyone. When you look at the manufacturing forecast, especially for workforce and the unfilled jobs, it is baffling and we have a lot of work to do. So it's good for us to work together and look at those opportunities for high school students, elementary students, from an agriculture perspective. There's a lot that's happening with regards to agritourism. This is fairly new, but this is an opportunity for us to think about some of those things. So, for example, when we take our kids to the pumpkin patch, maybe we can show them what a drone does. Maybe we can catalyze their interest in those ways. So those are some of the cool things that I think we can do to get kids interested in agriculture and to pursue some of these long-term career plans. And so one of the things I talked about with regards to the power of the supply chain, I cannot state this enough. One of the projects we worked on in my previous role was a wind energy project. And we recreated a wind blade with new materials, and they made it more recyclable. They made it faster to process. And then it was also a stronger material. But the point that was really interesting to most people is that there were 11 innovation partners on there. It was the entire supply chain. It wasn't one chemical company. It wasn't one manufacturing company. It was 11 different ones that were not competing in this space because they were all mindful of what needed to happen in R&D. You can go ahead and move to the next slide. Because those key learnings can serve as best practices in other manufacturing areas, including agriculture. So some of the things we learned in the wind energy industry are very parallel to agriculture. So for example, it's one thing to produce a wind blade, but then next, how do we test it? How do we look at it when it's out in the field? And talking about drones, drones are definitely a key part of what we can use in agriculture and then also manufacturing, thinking about how we can use them to look at maintenance, how we can look at them to plan ahead in terms of maintenance so that we can maintain before there's a problem, saving personnel time, saving materials. And there's a lot sometimes from a workforce perspective that we don't know until we have a drone out there. So from a wind energy perspective and agriculture as well, you may not know that someone is afraid of heights until they're out there on a wind turbine. So they may have all of the schoolwork and they may have all the training, but until they're out there, again, you don't know because there is a high percentage of people that have a challenge. There's definitely some turnover in that industry. You can go to the next slide. And again, it's all about the power of partnerships. So for example, I talked about the wind example with 11 partners. Hemp has over 25,000 uses. So as we think about our collective ecosystem, there's a lot we can do together. So in my previous role, we had chemical companies in the same room. BASF, Dow, DuPont, 3M, Owens Corning, they were all working on some of the same problems. They were looking at innovations. They were looking at how to prototype, what's the process, and what type of people need to be involved. At the end of the day, diverse input creates enhanced solution opportunities, and that's what we're trying to get at. There are also synergies with R&D funding and access to shared resources. So I heard you guys talk a lot about opportunity zones, and that is absolutely true in terms of thinking how we can increase speed to market, how we can have better commercialization. And from an ag perspective, these innovations are really going to matter in a big way. When you look at past, present, and future, what are some of the biggest innovations happening in the agriculture space? For one, blockchain, that's really important. It can be important for research. It can be important for inventory management. It can be important for a lot of different reasons. But basically having that information soup to nuts on what is happening out in the field can help you make better decisions and have more profit. Artificial intelligence, we love to talk about that because sometimes computers can think and identify problems well before we think we even have a problem. They can help with things like automated irrigation. So they can take the data from the weather systems, they can take the data from the ground, and they can help make sure we are making smart use of the resources we do have, such as water. We also have smart greenhouses that are out there that can have temperature regulation without wasting energy. That's another innovation that's happening right now. I talked a little bit about self-driving farm equipment. That's definitely something that is on the horizon. DNA testing of soil, that's something that is happening as well. And actually, in this photo, I really like that you can see different things working together. You can see the drone, so you can see the innovation. You can see the crops out on the field, and then you can see the wind blades. So it is all working together as a connected ecosystem. Okay, and that's part of the digital marketplace. Drones, we've talked about them a lot. They can help with productivity and energy. They can help with security as well. So a lot of times the security out in the field, maybe they're motion detectors, but drones can help us really identify specifically what is happening. Is there really a security issue? Is it maybe an animal? Are there safety issues? So if you're seeing something, maybe you don't have any type of repair that's needed, but maybe, so for example, for a wind blade, maybe it's a bird, maybe it's weather. For agriculture, maybe those are pests. Maybe they're alligators. I mean, we grow a lot of hemp in Florida. So those are things that drones can help us pick up on. If we see something large out in the field, we may need to identify what the issues are. And again, helping to problem solve for future issues. If we constantly see there are water issues, maybe we need to think about our irrigation plans. So what's happening now and how do we prevent it for the future? So an ounce of prevention is worth a pound of cure, they say. So just making sure we're thinking about that. And then again, prioritizing human safety. I know time is running up, but just wanted to mention a couple of the things we're doing. Again, we have HempBits / blockchain technology that's allowing us to view every step in the process. So from our perspective, from a CBD perspective, if you go out and buy CBD, you want to know where it came from. The technology is available now, so we can drill it down to the specific plant. So seed creation, where is the seed created? What's happening in harvest, which field, what were the weather patterns, et cetera, down to delivery. So that's something that is super important. And the innovations are very important for us in terms of making sure that this makes it to market and with the quality that we want. And that just kind of gives you a highlight of everything the last slide mentioned, so you can see the pills you get, the soft gels, where they came from. And then also on the bottle, we do have the technology so you can scan a QR code and you can see exactly what is in my product. So you scan that, you go to a website and you see the COA, which is a certificate of analysis. So we're integrating that. Customers aren't always asking for it yet, but our supply chain is, and we want to get ahead of this technology. Again, it's the power of the people because they're going to ask and we need to provide it for them. And ultimately, we're all part of the supply chain, whether it's genetics, whether it is out in the farm, whether it's cultivating, processing, or manufacturing. All of those steps in the process need to happen, and we need to have the power of the supply chain, and we need to have the R&D innovations that are out in the field and that we can collectively have, so that all the things we need to have to make it to market will do. And there's economic impact and a societal need for some of the things we're doing. You can go ahead and skip past that. Okay, so what's next? R&D happening, and there's more to come. So from a hemp perspective, we can look at biopesticides. So for example, hemp is antibacterial, so it could serve as a good pesticide. There are construction products that are out there in the field that we believe, again, hemp has 25,000 uses, so medicinal and construction, plus there are a lot more. There are patent applications that we have out there that have been submitted. I don't really want to talk about the details, obviously, but there's a lot we're doing in the R&D space, and we feel very excited about what the future holds for us. And then also, hopefully working with some of you guys. And that's it. So if you guys have questions, give me a shout. You can send me an email or reach me via phone, and I am happy to connect further.
Thank you very much, Robin. Excellent presentation by all three panelists. As you see, we are at the point of the hour where we're bumping into the next panelist. But I do want to thank you for joining. This presentation has made this particular summit fantastic. It's a great start for the Summit on Energy and Agriculture for the future over the next 5 years. You will constantly be called upon and asked to come back, and we will visit with you to work with you. The questions that we'll have, since we're down at our time limit, please submit the questions here and we will get them answered for you as soon as possible for those that are in the public. Thank you very much for participating in this panel. Any last message from anybody that are on the panel, beginning with Kamal?
No, I'm just thank you for this opportunity, and I'm glad to be with the other panelists, and hopefully in the future as well. Thanks.
Thank you. Noel?
Yeah, same. Thank you for having me. It was really exciting to be here, and it's great to meet the rest of the panelists and to be able to be up here with you. It was an honor.
Robin?
Again, just want to reiterate what they've said. Thank you so much. Great information, great sharing, and look forward to working with you all again.
Thank you. We will come back to you in the future. And Robin, I know that on the HAP side, I've been looking at some, Noah and I are looking at some programs there regarding using hemp for plastics to replace plastics, as it's being done by General Motors and BMW already on bumpers and panels and so on. So it's another conversation we can have in the future. And on the drone side, there's a lot of pilots that are looking for new positions and new jobs. And being a pilot for drones, different size drones will come in very handy as the industry is looking for you. So please, let's stay in contact. And thank you to the folks at NITS. You guys do a fantastic job out there. And biofriendly, what you are doing in reducing the emissions and bringing a better quality of air for us is awesome. Don't forget, folks, that in all areas, there's plenty of room for jobs, for employment, for business. Please continue to watch the summit the rest of today and tomorrow. Thank you again and welcome. Saludos.